guys, so we're going to just go ahead and pick up with where we left off. This is part B of 4-5C. Right now we're going to go ahead and take an equation and we're going to go back into a graph. So this is something we already know how to do. This is kind of just a more complex example. All right, so for this example here, we have 2 sine of 2 over 3x minus pi over 6. First thing I'm going to do here is I'm going to identify the period. In fact, you know what? We'll do the amplitude first because it's easier. The amplitude is just the number in front of the trig function, which is 2. My period here is going to be found by taking 2 pi and dividing it by b, except b is 2 over 3. If I keep it, switch and flip it, I get 2 pi times 3 over 2, which cancels to 3 pi. And so my period is 3 pi. Consequently, if my period is 3 pi, that means my quadrants are going to be split into 3 pi over 4, which is like 0.75 pi. Okay, my phase shift, that's going to be my period shift. That's whenever I set the entire inside equal to 0. So 2/3 x minus pi over 6 is equal to 0. If I move pi over 6 over, I get 2 over 3x. I'm going to multiply by the reciprocal here. Sorry I'm moving so fast, but this is not what the problem is about. If I go ahead and cancel by cross simplification, I'm going to get pi over 2 times a half, which gives me pi over 4. So I'm going to be moving to the right pi over 4. So let's start with scaling first. So I'm going to go ahead and scale this. I'm scaling this by pi over 3 pi over 4, which is 0.75 pi. It might be a little bit easier to interpret 0.75 pi, so I'm going to write that. 0.75 pi, 1.5 pi, 2.25 pi, and 3 pi. And then we can go a little bit backwards too. So negative 0.75 pi and negative 1.5 pi. Okay, so let's go ahead and start with this. This is a sine function. Sine functions start at the midline. They actually start on the midline. Typically, they start on the y-axis and the midline, which is the origin, but they don't have to. The sine function is being stretched by a factor of 2. But when you have a sine function that starts at 0, even if you stretch by a factor of 2, that's not going to change it starting at 0. The only thing that's going to change us starting at the origin is the fact that we're being shifted pi over 4 to the right. Pi over 4 is the same thing as 0.25 pi. So I need to go to the right 0.25 pi. So I'm going to do that right here. So my starting place is going to be right here, which means I'm going to go ahead and create my quadrant lines right here. Okay. My quadrant lines, each quadrant needs to be separated by a distance of 3 pi over 4. So we kind of walk this back just a little bit. I guess I could maybe be a little bit more accurate here. I guess we'll split this not necessarily into halves. We'll do thirds. So let's say that if I split this into 3 pieces here, that might be a little bit more accurate, only slightly. I'm going to split all of these into 3 pieces. That might make things a little bit more accurate. Okay, so I'm shifting over pi over 4, which is going to be right here. After that, I'm going to create my quadrant line like this. And then from there, I want to go a distance of 0.75 pi. So this is 0.25, 0.5, 0.75 is going to be right here. And I'm going to do that again. I'm going to go 0.25, 0.5, 0.75. And I know I did not draw this very well because they don't look super even. 0.7, 0.5, 0.5, 0.75. Here we go. All right. So I'm going to draw these quadrant lines to help me just make a more accurate sketch. Even though I didn't even scale it very well. Okay, so let's go ahead and start this. So the sine graph is going to start right here. In fact, I'm going to graph it in green so we can kind of see a little bit better. It's going to start right here. It has an amplitude of 2. So instead of going up 1, I'm going to go up 2 from the midline. So I'm going to go over 1 quadrant line to the next yellow marker, and I'm going to go up to a max of 2. From there, the sine function goes down to the midline again, which is right here. And then from there, it goes down to a minimum. This time our minimum is going to be 2 away from the midline, which is negative 2, which is going to happen right here on my quadrant line. And then it's going to come back up and end on my quadrant line here. And so my graph is going to look something like this, roughly. Okay, so let's move on to the next question. Next question, we have 2 sine of 2 over 3x minus pi over 6. So let's go ahead and start this. Easiest question to answer here is the amplitude. The amplitude here is 2. The period is found by taking 2 pi, divide by b, which is 2 over 3, which is going to be 2 pi times 3 over 2. And once again, we're going to get 3 pi, which means that my quadrant needs to be set up into 3 pi divided by 4, which is 0.75 pi. All right, let's go and find the phase shift. The phase shift is by finding whatever this is equal to 0, so the inside side equal to 0. 2 over 3x minus pi over 6. Is this the same problem? Okay, I apologize if you just watched me do that twice. That is literally the same problem. So I apologize. If I could edit that out, I would, but I can't. All right, this one is a new one. So the very last problem here, 1 over 10 cosine of 2x plus pi over 4. Okay, so this one, let's go ahead and see if we can graph this. Amplitude is the easiest thing to do. It's going to be 1/10. To find the period, all I need to do is set the inside equal to 0. We could set either 2 times x plus pi over 4 equal to 0, or we could set x plus pi over 4 equal to 0. The reason that I'm going to get the same thing is if I divide by 2 here, 0 divided by 2 is still 0, so it doesn't really matter. So I'm going to go ahead and solve it the quicker way. I'm going to subtract pi over 4, and I'm going to get x is equal to negative pi over 4, which means I'm going to go to the left pi over 4. The period in this case right here is 2 pi over b, but b is 1, so this one's nice and easy. The period is 2 pi. For quadrant, if the period is 2 pi, then the quadrant has to split that into fourths. So 2 pi over 4 turns out to be pi over 2. So let's go ahead and start sketching this. All right, so we're going to go by increments of pi over 2. 3 pi over 2, pi, and we're going to have, oops, I skipped one. Sorry, guys. All right, so we got pi over 2, we have pi, 3 pi over 2, and we're going to have pi. And I'm going to go ahead and create those quadrant lines like this on my scale. Okay. There we go. All right, so my amplitude is 1/10. I'm honestly going to maybe make this 1, and then we'll make it a 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so maybe we'll say this is 1 up here. So one little tick mark is going to be a 10th. You honestly could just scale it such that 1/10 is higher. It's up to you. But we'll say that this right here is 1/10. All right, so I'm going to the left pi over 4, so I do need to leave myself some space here. This is negative pi over 2, which means negative pi over 4 is here. The cosine function typically starts at 0, 1. In this case, though, the cosine function is going to start at a 10th. It's going to start at 0, a 10th, like right here. But I do need to shift it to the left pi over 4, so I'm going to shift it to the left pi over 4, right here. From there, I'm going to go ahead and create a quadrant line in red, and I'm going to create new quadrant lines from here. So basically, I need to go a distance of pi over 2 to get to my next spot. So right here, if this is pi over 4, pi over 4, pi over 4, we need to go a whole distance of pi over 2 to make it to the next quadrant. So what that means is if I go 1 pi over 2, 2 pi over 2, my new quadrant line is going to be right here. So basically all of the quadrant lines are getting shifted to the left pi over 2, like this. So all of them are getting shifted to the left pi over 2, like this. Okay, so I'm really just going to focus on the red quadrant lines now. Okay, so cosine is going to start up here at a max at 1/10. It's going to go down to the next quadrant line, the red quadrant line, at the midline. Then cosine is going to go down to a minimum of negative a 10th, which is going to be right here at the next quadrant line. And then it's going to come back up to a midline, and then it's going to go back up to a max of a 10th here. And so our graph is going to look something like this. It's the cosine function but it is super duper flat looking like this. Okay, that is the last question on there. If you guys have any questions, feel free to send me an email, or we can talk about this more tomorrow. I hope you guys have an awesome day. See ya.